In order to excel and or understand or comprehend this twisted assumption that I'm going to teach you today, you need to have a strong knowledge of what assumption is. So before we begin, let me just check with you all. Type a 1 in the chat box if you never heard of what assumption is. Be honest, all right? You may be thinking, is assumption the title of a new movie after Avatar? If that is the case, type 1. You never heard of it before. What is assumption? Or type a 2 if you are a rookie. Rookie means you have heard of that, somewhere, maybe from your parents, from your school teacher, or from me, but you don't really know what it is. Type a 2. Okay? Or if you are intermediate, means if you got some basics, you learn it before assumption. But then you can't remember exactly what to do. You need to polish up your skills. Type a 3. But if you are someone who is pretty advanced in assumption, you know how to use it, and in fact you have been using it most of the time instead of guess and check. Type a 4. Or if you are a grandmaster of assumption, grandmaster means in class you always volunteer to teach your classmates assumption. Type a 5 in the chat box. Do it now, everyone, so that I know whether to go a bit faster or slower. Let's see. Some of you put 1, some of you put 3. Is there a 3.5? Who can put 3.5? Did I say there's a 3.5? Okay, some put 2 only. Okay. So majority of you actually hovers around 2 and 3. Okay, so I think in that case, before I move to twisted assumption, I'm going to show you what assumption is all about. Okay, if you don't know what assumption is all about, you can't remember, it's very hard for you to pick up and understand twisted assumption later on. This is P4. You don't have this paper, all right? This belongs to P4 pupils. Those who were here last year, you probably have this. Now, P4 assumption, you don't have to take out that paper. I don't have to take out. I did this like beginning in term 1. All right. So I'm going to use this example to go through what assumption is all about. So for those who were not sure, don't know what assumption is all about, this is the time for you to pick up. Okay, I'll make it, because the P4 pupils can understand this. Surely you are in P5 now, you all shouldn't have much problem. Am I right? So for those of you who can't remember, this is a good time to revise again what assumption is. Okay, here it goes. There are 10 cars and motorcycles in a car park. Altogether, there are a total of 26 wheels. How many cars are there? When you are in P2 or P3, probably you will use guess and check. You will draw a table and suppose how many cars there are, how many motorcycles. The best way is to take 10 divided by 2 and assume there are 5 cars, 5 motorcycles. Then you find a number of wheels and add them together to see whether it tallies with 26. Is that right? So that's guess and check. So instead of using guess and check, you can use assumption method. Some teachers call it differently. All right. So I call it assumption method, and this is how you do it. Now, first thing first, when they ask for how many cars there are, now I'm going to draw a car park here. This rectangle here is supposed to represent the car park.
Draw the car park.
Yeah, draw the car park, draw a rectangle. All right. And then you're going to draw 10 vehicles. The 10 refers to cars or motorcycles or both.
Both.
Both. So we don't know how many cars, we don't know how many motorcycles, we just call it 10 vehicles. And this is what I'm going to do. I'm just going to like draw 10 lines. 1, 2, 3, 4, 5. One line represents one vehicle. Okay, so this is another 5 here. So there's a total of 10. Do it like what I have drawn on your screen. So there are 10 vehicles inside. Even if you know what to do, perhaps you were just memorizing. So today I'm going to explain in detail what every step entails. Okay, so it's good to revise. Okay, all done? All done with the 10 vehicles inside. We do not know how many cars, how many motorcycles. Maybe 5 cars, 5 motorcycles, maybe 6 cars. Not possible to tell. So what we're going to do is to use this heuristic called assumption. This is what you write down. Assume has the same meaning as suppose. All right, suppose all the vehicles are motorcycles. Write that down. suppose all the vehicles, the 10 vehicles there are motorcycles, and if they are all motorcycles, you know a motorcycle is how many wheels does a motorcycle have? How many? 2, right? How about a car? How many wheels does a car have? 4, right? Okay, good. So if they are all motorcycles, then I need to draw how many wheels in this car park? If they are all motorcycles, tell me how many?
20.
How do you get 20? Can I have an equation?
10 times 2.
Because these 10 vehicles are all motorcycles and every motorcycle has 2 wheels, so 10 times 2 is the first step. You get 20. Okay? First step. According to the question, am I right to say that they are all motorcycles?
No.
According to the question, how many wheels should there be in total?
26.
So I need to add in how many more wheels into the car park?
6.
How do I get 6 if I want an equation?
26 minus 20 goes to 6.
Are you all with him? This is the second step. The first step, perhaps I will just add in this word here. This is the total number of wheels if I assume they are all motorcycles. However, according to the question, there should be 26. So I need to add in another 6 more wheels. So I'm going to get ready 6 wheels here. I'm going to use a black pen to draw the 6 wheels. 1, 2, 3, 4, 5, 6. All these 6 wheels are supposed to go right into the car park. Now, can I just bring 6 wheels and put into one vehicle?
No.
Then how? How many wheels must I add to the motorcycle to make it become a car?
You put 2 wheels in each vehicle.
But I thought a car got 4 wheels. Can I go and put 4 wheels inside one vehicle?
You put 2 wheels in each vehicle until don't have any more.
Because there are already 2 wheels, right? Because we already assume they are motorcycles. So you need to add 2 more wheels to a motorcycle to make it become a car. So the third step is to find the difference between the total number of wheels of a car and a motorcycle. This is called difference, D-I-F-F. Can I write in shorthand here or short form? All right. So I just have to put 2 more wheels into a motorcycle so that it becomes a car. And this is what I'm going to do now. I'm just going to take 2 wheels, put into this vehicle. Can you see that this vehicle has become a car now instead of a motorcycle? So I go to the second set of 2 wheels and put it over there, and this has becomes a car now. And then lastly, the third set of 2 wheels into the third vehicle, and it has also becomes a car. Can you all see that? So from the diagram, how many cars are there?
3.
How many wheels are there in the car park right now?
26.
So it's very clear, right? Now, how do we get 3 for the final answer? There's a 4th step involved. You know how do we get 3? We take the 6 wheels that we wanted to put into the car park, and that is actually derived from the second step. Can you see that? Second step, the 6 there. What about the 6 wheels? I need to put them in groups of 2. Why in groups of 2? Because every motorcycle should have another 2 more only. Cannot have more than that. So when you take 6 divided by 2, because you're putting it in groups of 2, you get 3. What does the 3 represent? It means there are 3 sets. This is first set, second set, third set. And every set will eventually be brought in to make a motorcycle become a car. Therefore, the 3 there also refers to the number of cars. In other words, step 4 is to take the answer for step 2, divide by the answer of step 3. Step 2, the answer is 6, right? The number of wheels that we need to add in, divided by the answer to step 2. We are putting them in groups of 2 to get how many sets. And the 3 sets coincidentally also refers to the number of cars there. So these are the 4 steps of assumption. Have I explained slowly and clearly why we are doing this 4 steps? It's not because my teacher say first step must do this, second step must minus, third step must find it. No, you have to understand what goes behind the equations. All right, then you don't have to memorize anything because you understand. Any questions? No questions? Can I ask you a question? Can I assume all are cars?
It's possible, but it's easier to do with the
It's
motorcycles.
I want you all to know both assumptions, because for twisted assumption later on, you need to know the other. I tell you why later. Let's do the other one first. To assume, this is second method, all are cars. We are going to do it the other way around. So same thing, I want you to draw a car park. Won't take you too long. Don't have to be like arty-farty and draw nicely. No need to be 3D. Okay, just draw another car park. And again, the number of vehicles is supposed to be 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, same thing. Assume all are cars. If they are all cars, how many wheels do you think I should have? If I think that I suppose that these 10 vehicles are all cars, how many wheels do you think I should have in the car park, if that's the case?
40.
40, because every car got 4 wheels, right? So it's going to be like, what's the equation?
4 times 10.
Okay, or it should be 10 times 4 because it's 10 sets of 4. All right, so it's 40, and that 40 again represent the total number of wheels. But according to the question, are there really 40 wheels in the car park? Are there? No.
No.
How many wheels should there be?
26.
But I got 40, what must I do?
40 minus 26.
Very good, you all heard him. The second step would be to take 40 wheels in the car park. Right now, take away the 26. Because it's only supposed to be 26 and you will get 14, 1, 4. So what does the 14 supposed to mean? If I want a word to describe the 14, what would it be?
Take away or
Remove,
subtract.
take away, okay? Can I go to a car and just remove 4 wheels from this car? Then I don't know what vehicle is that, no wheels one. Can I?
No.
How many wheels can I remove from a car?
2.
2, because you cannot have no wheels, right? For that vehicle, you need to have at least 2 wheels. So what she's trying to do is she's going to transform a car into a motorcycle, because apparently some of them are motorcycles, not all of them are cars. So she just have to remove 2. How do you get 2? Can I have an equation to represent that? Look up, same third step.
4 minus 2.
A car got 4 wheels right now, and I want to make it become a motorcycle. I just need to remove 2 wheels from the car to make it a motorcycle. Same method, same equation, but the reasoning is a little different. All right. So anyway, it's still about the difference between the number of wheels of a car and a motorcycle. So that's 2. How many tools must I remove so that in total I can remove 14? How many tools?
7.
How do you get 7? What's the next equation?
14 divided by 2.
Again, can you see this is the second step answer divided by the third step answer? Can you see that? 14 in the second step, divide by 2. That's always the fourth step. So what this 7 represent is that I must go to 7 cars to remove 7 sets of 2. So I've gone to the fifth car here, 6th car here, and then the 7th car. So can you see I have removed 14 wheels because I crossed them out. I don't know if you can see on your side. You need me to blow this picture up a bit. Can you see? Are you able to see now? I have removed 14 wheels. I struck off 14 wheels. So what does that mean? What does the 7 mean now? It means that I need to go to 7 cars to remove the wheels. And I'm only left with 7 what? 7 motorcycles. Can you see that? Because I removed 14 and it's going to be outside, 14 wheels outside already. So I've removed 14 wheels, and indeed now there are 26 wheels in the car park, and that 7 represent motorcycles. You realize that the fourth step answer is always the opposite of what you assume. When you assume all are cars, the fourth step answer will always give you the opposite object or vehicle in this case. Just now I assume all are motorcycles. The fourth step give me the number of cars. All right. So we need to have one more step. So what is the last step here if I want to find out how many cars are there? How many vehicles are there all together in the first place?
10.
10. And out of the 10, we just found out that 7 are motorcycles. So
minus
it's a
7.
matter of 10 minus 7. So the 3 is 3 cars. So what I'm showing you is that we still end up getting 3 cars. You can assume either one, whether they are all cars or motorcycles. But in P4, whenever they want you to find out the number of cars, you just assume the opposite. So you assume all are motorcycles. That way, you just have to do 4 steps. If you assume the opposite when they want cars, you just finish 4 steps, you get the answer. But if you don't want, you still will end up getting the answer if you have, but you have to do 1 more step. Okay, for P4 normal assumption, always assume the opposite. That will be great because you can do it in 4 steps. With this example, you think you are all right? You sure? If that's the case, can I get everyone to try question 1 in your twisted assumption? Because that question 1, I deliberately put in normal assumption as the first question to let you have a sense of it first.